You're deadly silent tonight, huh? You guys, any questions? Do you want the class tonight? Oh, shit, can you hear me, guys? Hello.
Yes, we can hear you.
So no questions?
Yes.
Okay, then I'll see you for the test. Oh, yeah, bye-bye.
No,
Huh? Why not?
sir. I have an ask here. Ne?
Yeah.
When it comes to this electronic control of AC motors, what are we supposed to do there? The examples, because I only see one example.
Yeah, it's theory.
Theory. Oh, it's
Yeah.
theory. Okay.
Hmm. Okay, let's look at number 5 of these exercises. It says 100 volt shunt motor has a field resistance of 50 ohms and the armature resistance of 0.5, and the speed is 1000 revs per minute, and the current I load is 10 amp. The total resistance of the field is reduced to 3/4 of the value. So how much is 3/4 of 50?
3/4 of what?
Sorry about that. Find the new speed and the current taken from the supply. So we want N2 and I load 2. Let me just switch the camera here. New share.
Ma come se leswi swi nga le endleni la?
All right, so what do? First of all, I field 1 is 100. Divide by 50. That is 2 amps. And E1, V minus IA RA. So that is 100 minus 8 times 0.5. That means it's 96 volts. Because if you look at the drawing, right, we are coming in with 10 amp, and that is 2 amp. So therefore, the armature current is 8 amps. Now, in the second case, the resistance is reduced to 3/4 of that. So the same thing will be if we take IF, 3/4 of that, which is most the same thing. So that is 6/4, which is 1.5. All right, so E1 over E2 so there we have that. So 96 over E2 is 1,000 times 2. Oops, and then we've got N2 and 1.5. So what's going to happen now? Anybody? Now, what if I've asked this in the exam? What are you going to do? Let me just see something there. Guys, we are wasting time. What is going to happen? So if we try that, and we say E1 is 96, is constant times 1,000 times 2.
Sir,
Yeah?
from the statement there on the question, it said that if the total resistance of the field circuit is reduced to 3/4, not the actual feed current.
Oi, oi, oi. Let me show you. It's 150 divided by 4. That is 37,5. Right?
Yes.
So 100 divided by 37,5 is how much? Okay, so that makes a difference. I thought it would be the same, okay? So that gives us 2.667.
Nunca se mais então me desse 100 rands, aí não vale muito. Então aquele que eu vi lá, uma assim que tinha tipo de capacitar me 150, esse que ela é 50, né? Deixa eu ver. Tem um assim, vai se meter assim, vai entrar, vai se meter assim, vai ficar assim, tá, vai tapar uma cerca. Tem aquela lá aí, sabe que filme combate motor, né? Yeah. Talvez tipo Scorpion. Aquele moto. E aquele Scorpion. E aquela aí, você costuma, você tem bandeira respirar. Vita lá 150. Agora deve encontrar com o B, quando não vender aquele lampa aí, barato.
We'll stuck with that. That doesn't help us much. So what do you suggest we do? They say that the characteristic curve or the excitation curve is a straight line. So for 1 and 2 amps, we have 96. So for 2.667, what is the voltage that we're going to have? So 96 over 2 must be E2 over 2.667. So therefore E2 is going to be it is 128.16 volts. So therefore is 128. Yeah, well. So that is 0.749 is equal to 1,000. That is what we get. So we get 1001.13 revs per minute. And the current will be E is equal to V minus IA RA. We have 100 volts here and 128. No, 128 is equal to 128.16. So the current drawn from the supply will be 56.32 amps. I line. So do you see how you tackle these type of problems? You have to look at all the options and what is given. Okay?
Yes, sir.
Right, it seems we're gonna run out of time in 10 minutes, so be ready for the next. Oh, it says in 5 minutes. Okay, doesn't matter. Any more questions?
Sir, is there any special approach to that type of a question, sir? Since well, the way you solved it, it's kind of new to me, sir.
Why? The big thing that you must remember is what they said about the flux or the graph of the excitation. It is in a straight line.
Yes, sir.
So now we have a ratio that we can say 96/2 is the same as E2/2.2667. That is a graphical solution.
Okay, sir.
Okay, just check that out. Now the big thing, this comes with practice. You must be practicing this stuff not till you get it right, but until you can't get it wrong. That's the only way to study. Do all the examples that you can lay your hands on and make sure you understand the principles behind it. Then everything will be going according to plan. Okay, any other questions? Guys, don't be afraid to ask a question. Remember, if you don't ask, I think you're stupid. And if you ask, I know you are.
Okay, sir. Since well, okay, I arrived a bit later, so I joined the group a bit later, so I did not understand your explanation on that 3/4, on that the same question, sir.
All right, they said if the resistance is reduced to 3/4 of the value that it was,
Yes, sir.
so then 3/4 of 50 is then 37.5. So that is the resistance now.
Oh, okay, sir.
Okay.
Okay, sir.
Someone else? Do you want another 40 minutes or can we say goodbye after this?
Okay, so does this mean that the tomorrow class is no more, sir?
Oh, it seems you guys don't have a problem.
Yeah, it seems that way.
Damn, I'm a good teacher and you clever students, huh?
Not sure, sir.
But any case, if you want, just let me know. Oh, we can carry on now.
I'm not sure. Okay, so the last time said they asked the question whereby we said we're going to ask it tomorrow. It was 30.40, sir.
30.40.
Yes, sir.
Let me just quickly have a look at that one.
Sir,
The
example that you just did right now, which example is it?
That's from the exercise.
From
At
the
the end of the,
exercise?
yeah, the exercise at the end of this chapter.
Oh, okay, sir.
I'll show you now. Oh, come on, go down. What's wrong with this thing? You see, that exercise there was number 5. Okay, it seems time is running out. I'll send you the next link. Then I'll do some more
Yes.
questions.